A couple of weeks ago, the Tailscale team were at KubeCon in Atlanta, and they were kind of surprised by how few of you knew that Tailscale has a Kubernetes operator. So now you know, but what does it do? Well, it has three main pillars, the first of which is the API proxy. This API proxy basically means that you never have to log into your Kubernetes cluster ever again manually. It reuses the identity of your Tailnet connection to automatically log you into your cluster. Second is ingress, so you can use Tailscale to automatically provision TLS certificates on your Tailnet, so you don't have to worry about some other cert manager process or something else going on in Kubernetes. There's also egress and also cross-cluster, sort of multi-cluster connections between different clusters on your Tailnet. And I think one of the more interesting things about this is it's completely agnostic of the Kubernetes cluster provider underneath. So the team were like, Alex, we're going to get you to spin up clusters on EKS and Google Cloud and everybody that offers hosted Kubernetes solutions these days. But you know me by now. I like to self-host as much as I possibly can. So enter Talos Linux. This is the Kubernetes operating system. It's just Linux, but it's Linux like you've never seen before. So what do I mean by that? Linux like you've never seen before? Well, typically with Linux, you would install the image from an ISO and then you would boot into it and then you'd run a bunch of Ansible scripts or something to configure that Linux box and convert it into whatever role that that box was going to fulfill for you and your organization or in your home lab. With Talos, though, it's completely API driven. And this is really quite a paradigm shift. It's a big mental model shift in your head because these machines boot up and they have absolutely no idea what their purpose in life is. The ISO is just completely plain. It's got everything it needs to spin up a kubelet, some basic Linux kernel parameters compiled in. Essentially, it's got everything it needs to be a Kubernetes control plane node or a worker, but it doesn't know anything about how to connect to the other nodes in your network, if they even exist, or really anything much about the world at all. So what we have to do is via the API that this node exposes, we have to connect in using a tool called Talosctl and remotely configure and provide configuration files to those remote nodes in order to tell them, well, what their purpose in life is.
What is my purpose?
Pass the butter.
And so this means that you can destroy a node and bring it back up and then reapply a config from a different node 20 minutes ago with no persistent state whatsoever. And it will just come back up and think, you know, it's the ultimate culmination of the cattle versus pets discussion in the Kubernetes universe that's been going on for the last decade or so, I think, since CoreOS was born, sort of 2015 era. Now, the Talos project has a fantastic getting started guide here by Justin Garrison over on YouTube. Highly recommend you go and watch that. But also, they have really some pretty great documentation here. So what I thought we'd do in today's video is spin up a really basic single node Kubernetes cluster using Talos on top of Proxmox, and then install the Tailscale operator and show you that you never even need to log into this thing. There's no kubeconfig files. I mean, they do exist technically, but the API proxy part of the Tailscale operator transparently maps to cluster roles under the hood so that you can log in as a system admin or any other RBAC user or profile that you've created in your cluster. So that's what we'll show in today's video, and there'll be chapters down below if you want to jump around. You know, if you've already got a working Talos VM or you don't even care about spinning up your own Talos stuff, then you can just skip to the next chapter or two where we just configure the operator instead. Now I'm going to do this today on the little Dell 1 litre PC that's in the rack just down there behind me. You really don't need much to get started. And Talos will run on bare metal as well. So if you want to completely take Proxmox out of this equation, you absolutely can do. However, whilst you're learning, certainly I found in the last week or two that I'm spinning these things up, I'm destroying them, and I'm kind of making mistakes, and that's much easier to do in a virtual machine and get the concept square in your head and then move on to the bare metal later on, which will be coming as a separate video series in the channel, because just there, that little blinky red light, that is a 3-node Lenovo M720Q Kubernetes cluster. Kubernetes? So we need to first of all download our Talos Linux image from their image factory. And these are a bunch of pre-baked images that contain a few useful utilities, to be honest. So let's say you wanted to do some hardware acceleration, you wanted to run a jellyfin or something inside this cluster. Well, you're going to need Intel GPU drivers. Or let's say you want to do some local self-hosted AI with an NVIDIA GPU. Well, you're going to need the NVIDIA drivers. These image factories contain all of those little bits and bobs inside the images. So I see no reason to do anything other than the latest right now. So I'm going to do that, 1.11.5. And I'm going to scroll down and look for, where is it? Proxmox, is it here? Yeah, there we go. No cloud. So you see how Talos is designed to run and has a bunch of optimizations, presumably in the kernel they've compiled for all of these different providers. You know, like Amazon famously runs on Zen. Some of these other guys run on Linux KVM, that kind of optimization. All right, so we're going to just do the no cloud option right here. Click on next. AMD 64 is fine. I don't need secure boot for a virtual machine, although if you need it, that option is there. Now, in terms of system extensions, I actually started off making this video series with Tailscale installed. But if you do that, you're going to run into some kind of clashes in the networking side of things later on. So as tempting as it might be for me to put Tailscale in every base image on everything on the planet, I'm actually not going to do that today. What I do need, though, are these QEMU guest agent utilities. So I'm going to select that. And this is so that Proxmox can actually communicate with the virtual machine properly. It will be able to get things like the IP address of the virtual machine. It will be able to do things like giving it graceful startup and shutdown procedures, and it's just going to make for a better experience overall. So have a look at this list of system extensions. They are quite extensive. You know, maybe you need, oh, I don't know, there's the i915, for example, for the Intel drivers, that kind of thing. So all we need right now are the QEMU guest drivers. I don't need any other kernel customizations. That's totally fine. So you can see there are lots of different options here, and you can use this to feed into any of your config management systems. In fact, there's a tool called Tal Helper, which essentially allows you to automate the process of creating Talos virtual machines and even bare metal configurations as well. It's very helpful when you want to put this stuff in source control and encrypt secrets and all that kind of stuff. We'll come on to that later. Don't worry about that. But for now, all we want to do is download this ISO right here. Once the ISO is downloaded, the next step is to go to your Proxmox, wherever you store your ISO images, and just upload that image. I'm actually going to just get the URL of the image rather than uploading the ISO directly. I'm going to download it from a URL instead and download that to my Proxmox instance that way. Now, once this is finished downloading, we're going to create the virtual machine and then install Talos inside that. Okay, download complete. Now we want to create a virtual machine. So let's do this. Let's give it a number of, I don't know, 1111. And I'm going to do Talos 1. At the moment, I think I'm just going to do a single node cluster, but typically it's good to have, I don't know, like Talos Worker 1, because if you have multiple virtual machines to run as worker nodes, whatever, it's just good to have that naming. However, for now, Talos 1 will do us just fine. All right, so the ISO is no cloud. System, I'm going to leave all of this as default except for QEMU agent, which remember we added to the ISO a few minutes ago. Disks, sure, 64, why not? SCSI, yep, that should all be fine for our purposes. Cores, 4, yeah. Memory, I'm going to give it 8 gig because, well, actually, I'm going to give it 16. That's probably way overkill, but that will do just fine. And then the network, all right, let's start off to create it. I think that's all we need to do. Creating the VM is really the easiest part of this whole process. And you can see in the console, now it's picked up the ISO and it's going to boot from that ISO. And so once it's booted, how do we interact with this thing? We can't SSH into it. We can't go over it. We can't go under it. We can't even go through it, right? So how do we interact with it? Well, we use Talosctl to do that. Now, this command is, well, first of all, it's really got a very extensive help section built right into it. But let's just say we wanted to understand what the disk layout on our remote node looks like. So first of all, we have to get the IP address of that remote node. So we do that by going here and looking at the console, 192.168.1.194. And because we have the QEMU guest tools installed, that will also show in our Proxmox console just here as well. So what we can do is we can construct a command like this, talosctl get disks, and then we have to pass in -- insecure. That's because this node it's not bootstrapped, so it doesn't have any certificates generated at this point. It's just, remember, it's just it's a butter robot. It doesn't know what its purpose is, okay? So then we pass in the IP address, and you can see that it prints out a pretty handy dandy little table of all the different disks that this virtual machine can see. You recognize some very basic stuff here, like SDA. On a Linux box, this would be sort of like dev SDA, like you would see in an FS tab or something like that. So we know that these virtual disks exist inside the system. So what we can do now is we can generate a Talos config to pass to that node. Again, we'll pass the config using the API to that remote node over the network and tell it what its purpose in life is. Now, a really interesting thing about Talos is that it actually runs out of RAM. So you can boot from this ISO and then pull the USB stick or pull the ISO out of the machine, depending whether it's a virtual machine or a physical machine. And Talos basically bootstraps itself into memory and then k-execs itself into existence. It's a very, very cool system. So let's jump back to the Talos documentation for just a second. We've downloaded our Talos ISO, we've booted our machine. We now need to store our IP address into an environment variable. So I'm going to go ahead and do that. I'm going to export this control plane IP, was it 192.168.1.194? And so this is going to create what's called an environment variable in my shell. So if I do echo now control plane IP, it prints that out, and it means we can use that value in scripts, which we're about to use with Talos. So going back to the getting started, we're only going to have one node, so I'm not going to do the control plane and worker thing, just literally got one node. Now, I don't actually want to do any static IP configurations. I want this to all be completely DHCP. So luckily the leases in my router will last for a few hours, but just bear in mind that you might want to set a static IP reservation based on the MAC address of this node in your router so that it gets a static IP, but it's configured. Well, it gets a DHCP IP, I should say, but it's statically mapped inside your router software using the MAC address. So you don't need to provide static IP configuration to the virtual machine or the bare metal node, but it still gets a stable IP within your network. Okay, now the next step is to learn about our installation disks. And hey, look, it's our old friend, talosctl get disks. And this time, because we have the control plane IP set as an environment variable, we can actually see what's going on a bit more easily. So if I'm going to run this one more time, we can see that SDA is going to be our install target. So now we're going to actually generate our cluster configuration completely manually. We're going to have a video next week, or it might be January, honestly. But I'm going to have a video where we go through a bunch of Terraform and OpenTofu code that I've written to automate this process using a talhelper command and Terraform code as well. All right, so let's give ourselves a cluster name of, I always like Bob. I don't know why, but I do. And then the disk name. So that's going to be / is it just dev SDA or is it? Yeah, okay. So the install disk, we have to put in, oh no, so the environment variable is just SDA. Okay. That's a little confusing, but we'll get there. We'll make it work. And we're going to take this value from here. So we know that this 69 gigabyte disk is what we're going to use to install Talos onto. It's just the boot volume. It's where var/lib and all our our containers will live. This is the node storage itself. In terms of stateful storage for your pods and things like that, that could live on here if you want to do like host path mapping, and just don't do that. Use Ceph, use NFS, use literally anything else other than a host path map. However, this is only a single node cluster, so it might actually not be that big of a deal. But anyway, storage is a whole other conversation. That's not part of this video. Okay, so now we've created our cluster name and our disk name. I'm going to run this command of talosctl genconfig cluster name. But first, I'm just going to make a directory here called Bob. I'm going to change into that Bob directory. And now I'm going to run my genconfig command. So we're going to ingest our cluster name variable that we set. We're going to ingest our control plane IP variable that we set, along with SDA for the install target disk as well. And now you'll see that there's a few files being created as part of this process. In fact, let me bring up VS Code. That might be the easiest way to show you what's going on here. So these three commands, these three files, sorry, govern exactly what your Talos cluster is going to look like. So you've got it's a very, very long YAML file. I think it's about 500 lines or so just for the control plane. There you go, 552 lines actually. But it governs everything that this node is going to do. So it turns this from a boring old plain virtual machine into a butter robot, or in this case, a control plane node. Now, we're not actually going to use the worker config in our example today, but again, this would configure everything that needs to be configured as it pertains to being a worker node within your cluster. You can see we've got things like the certificate authority that's being configured here, the root CA, and all of these certificates live in here. So you might want to, if you're going to commit this to source control, use something like SOPs to encrypt those values. But again, we'll come on to that in our automation video later on in this sort of Kubernetes for Beginners series. All right, so we have our three files from this command. We have the control plane, the worker, and the config. Now it's time to actually apply that configuration. So first thing that they have us do in step 7 is apply the control plane.yaml to our remote, well, control plane node. It's only a one node cluster, as I keep saying, but we're going to apply that config again using the insecure self-generated certificate that this node generates for its own API right now. And then we're going to apply that YAML file to that remote node. I'm going to jump real quick over to the console of this node, because what you're going to notice is in the background, this thing is now starting to install itself. Look, stage installing over here. This will take 5, maybe 10 minutes, depending on the speed of your internet connection and the performance available to this specific node. I've noticed that there are quite a few errors scroll by in the console. You see things like error evaluating disk locator. Don't worry too much about that. There's a bunch of what I think, they're not necessarily bugs, they're just like race conditions in terms of things being done that expect other things to be done at the same time or are in process of being done. It does almost always seem to figure itself out, so try not to worry too much and just be patient. This node will reboot itself. It will re-kexec and rebootstrap itself once it's finished installing. And then you'll notice that things like the stage here goes from installing to being ready, and then the kubelet will be ready, and all of that stuff, it will figure itself out. But like I say, it takes maybe 5 to 10 minutes. The node just rebooted. It didn't go all the way back to the BIOS. It just closed down its virtual RAM environment version of itself and then re-kexeced into the newly installed version of itself. This is so cool. This is so cool. And now you can see that the stage of the install process has changed from installing to booting over here. And we can see the cluster name of Bob is here. It's only got one machine in it, and the kubelet is healthy. Now what you want to look for is this message right here where it says etcd is waiting to join the cluster. This is where we go back to the Talos documentation. We need to set our endpoints for Talosctl, and we're going to do that just by copying this command right here, where we ingest the Talos config that we generated in the previous step, and it's going to set the endpoints for Talosctl. So this is how it knows to communicate with the endpoints inside your cluster. The next thing, and this is really important that you only do this once on a single control plane node as they document right here. We're going to bootstrap etcd just with this one command. This is how easy it is with Talos. We just do one command, it bootstraps etcd, and within a couple of minutes, we have a fully working cluster. It's actually kind of amazing. So how do we verify that that step succeeded? Well, we need to use Talosctl. I hope you're getting the picture by now. You don't connect to these nodes and go on the terminal and type stuff, and it's all done remotely through the API. So long as you know this IP address and you set up your endpoints in your Talos config, you're good to go. So what we need to do is export this variable here called Talos config, and we're going to set this to the path in our directory here where the Talos config file lives, which is actually just literally right here in this directory. So export Talos config equals, actually I'm going to do .talos config. And now hopefully when we do a Talosctl, not Tailscale, it's muscle memory, Talosctl config info, it can connect to our remote cluster and tell us what's going on. So let's now run a Talosctl health command. I'm going to pass in the control plane IP of the node, and we can see that all of the various checks that the health command here is doing are present and correct. So let's grab our kubeconfig next and actually connect into Kubernetes properly. I'm going to do this one here where I specify a specific file name, because once we've got Tailscale Operator installed, we're not actually going to need our kubeconfig ever again. So let's just run this command here, Tailscale kubeconfig alternative kubeconfig. And this is going to go to the cluster, grab the kubeconfig to our local machine, and then I'm going to export this environment variable here to my cluster, so I can now to my local laptop, sorry. So I can now run things like kubectl get nodes. In fact, let me resize this window, because I had a bit of feedback from somebody a couple of weeks ago that once it gets to the bottom of the screen, they can't see what I'm doing. So we're going to do kubectl get nodes, and you can see I've literally got a working Kubernetes cluster. Okay, it's got one node in it. I can't schedule my workloads on this one node cluster yet, but with just a couple of steps and maybe 5 or 10 minutes worth of your time, I know a lot of people use Kind for local cluster development and things like that, but that puts a lot of workload on your local laptop. And for me, I like to outsource all of the thought work, all of the heavy lifting to remote stuff that I can put out of sight, out of mind. Computers really shouldn't be seen or heard in my world. If I can hear a computer, there's definitely a problem. And I'm going to spend money to try and fix that. So anyway, we can also now check the node health. I think we probably already did that one with the health command, but yes, we can see that one passed already. And then again, we're jumping ahead, aren't we? We verified the node registration is all complete, and really the world is now your oyster. So the next step in our operation is going to be to make this single control plane node a schedulable node, so we can run workloads on this single node, and then to also deploy the Tailscale operator. So as I keep saying, this is a single node cluster, and I want to be able to schedule workload pods on the control plane node itself, because it's doing double duty. It's being a control plane, it's being an etcd host. It's also going to host my workload pods in this scenario. So we need to modify our Talos Linux configuration file to allow scheduling on the control plane, as you can see in this documentation from Talos right here. So I'm going to copy these 2 lines and edit my control plane.yaml file. All right, so back in VS Code, you can see these are the files that we generated earlier in the video to configure Talos. And I'm just going to paste this in right here and fix the indentation, press save, and then go back to my terminal and do apply config. So this is, I'm going to need to remove the insecure because we have bootstrapped the node since we last ran this command. But this is one of the fundamental differences between Talos and normal Linux. We do all of the configuration in code, in files, and then we apply those configs. Now, in the Kubernetes world, this is nothing new. We've done kubectl apply -f for years and years and years. But for managing the underlying host, this is really a huge paradigm shift. And it makes me really kind of want an application-centric version of Linux. So like Talosctl, but remove all the Kubernetes stuff and just give me a Docker host that can do this for like home lab type stuff. That would be so cool. Anyway, I digress a little bit. Oh, I think I might have messed up the indentations a little bit here. Yes, I have. Okay, so I don't need a second cluster definition, and I certainly don't need it under the machine definition right here. So let me jump back to where it says cluster and then paste in right here my allow scheduling on control plane. And so this is where that parameter should live. These long YAML files, it gets a little bit confusing sometimes, but we figured it out. We got there in the end. At least I hope so. There we go. All right, so I've now applied that configuration without a reboot to that remote node, and you probably won't honestly even notice anything really that different. I mean, the machine looks the same, but we can now schedule workloads on it as well. So just to belabor the point really about how you interact with these things, I want to now reboot the node that is the control plane. So I'm going to reboot control plane IP. And this is a really cool command. So in the background, you'll notice that the machine is now rebooting. It's doing a bunch of stuff in the background in the console. Whilst I have this interactive reboot command running, how cool is this? So like this is doing, in the old days, we had to wait for Ansible to do all sorts of crazy hacks with asynchronous reboots. I think it's much easier now with like the reboot module, but certainly in the old days, this was a very difficult problem to solve. And so Talos now is rebooting. It's not actually rebooting the entire node, it's just restarting the whole kexec process that I keep talking about. But as soon as this node comes back, you can see that this interactive reboot command is looking at the various stages that the API is communicating over the network to it to say, am I ready yet? Am I ready yet? And as soon as the pods and things like that come up underneath that it needs to run the Kubernetes cluster, the status will change back to ready and you should be good to go again. So this is in this way you can apply declaratively configurations across your entire Talos cluster. You can upgrade the images of the nodes themselves. You can apply config changes like allowing workloads to be scheduled on your control plane nodes. You can turn things on and off and change all of your pod networks, and anything that you need to configure for Kubernetes is configured in those YAML files. And this is how you apply those changes. It's so cool. And indeed, in the time that I was just waffling on there, you can see that now the post check has passed and this node is now back up and running. This doesn't necessarily mean that kubectl will work anymore, although in this case it actually did. But sometimes it's the case that the node is back up and the cluster is still unhealthy and still figuring out the API hasn't come up properly yet. But in our case, it had. So that's how you make the workload schedulable on the control plane for a single node cluster. Let's now move on to installing the Tailscale operator inside this cluster. Now this process is relatively straightforward, but there's just a few steps we've got to do to get there. So let's begin installing the Tailscale Kubernetes operator. This process is relatively straightforward. There's just a few steps to go through we need to do in order. So let's do them. First of all, we need to make sure that we've got all of these prerequisites taken care of. I'll put a link to this piece of documentation in the description down below, of course. Now, this Kubernetes operator must be configured with Tailscale OAuth client credentials. This is because it uses those OAuth client credentials to generate the auth keys needed to authenticate various nodes throughout your Tailnet. So the first thing we want to do is modify our policy file, as you can see in step 1 here. This Tailnet policy file, you may well know it as our ACL file or our grants file, but it can be found at tailscale.com. Go to the admin console and then click on access controls. We next want to look for this tag owners section. If you don't have one, create it, and then paste in the values from the documentation. I just need to clean that up briefly. Now, a nice little thing about the ACL JSON editor is that when you don't indent things properly and you click save, look at that, it fixes it for you. It's a small thing, but I really like it. All right, so the next step is going to be to create an OAuth client, as we can see right here. So let's jump to the trust credentials area of the admin dashboard. We'll go to settings and then trust credentials. And I'm going to create a new credential right here. I'm going to call it OAuth. I'm going to call this K8s vid. Going to click continue. Now we need to create the client with the following scopes. We need devices. We need devices core, read and write. In terms of a tag, this is required for the right scope. So I'm going to put on this one the K8s Operator tag, as the documentation suggests. Next, I'm going to go down to keys and look for auth keys and do the same. I'm going to write that. And again, the K8s Operator tag will be automatically selected. Finally, I'm going to look for services, which is up here under general, and then also click on write as well. And this is because the api-proxy will automatically use the brand new Tailscale services feature to create a service for you and automatically load balance between your Kubernetes API pods. That's very cool. All right, so we've got our credential right here. Now note these values down somewhere securely. They are basically like a password. So, standard rules apply with secrets. So we don't want to really ever do anything in a Kubernetes cluster manually. However, for the purposes of today's video, I'm going to just do things manually piece by piece using Helm charts. Long term, I'm going to do a bunch of videos around GitOps and applying this stuff using Flux, Argo CD as well in the long term. But for right now, at least, we're going to do everything using the Helm method here rather than the static manifests method with kubectl, just to get things moving along a little faster for the video. All right, so next thing we need to do is add the Helm repo to our local node. Now, all of these commands that I've been running today, like Talosctl, Helm, there's a bunch of like kubectl as well, of course. I use Nix Darwin to manage the configuration of brew on this machine, but all of these tools are available in Homebrew. So you can just go to brew.sh, search for the tool that you need and install it that way. So Helm repo add Tailscale, that's now been added to my repositories. I'm then going to type Helm repo update. This is kind of like doing apt update in Debian land. And now I'm going to paste in this command right here. And I'm going to copy in the secrets that we just generated in the previous step. So this is going to install the operator, passing the OAuth client credentials to the Helm chart to automatically bootstrap the operator. So the operator does not exist, and it's now going to go ahead and install the Tailscale operator inside your single node Talos Kubernetes cluster. So let's take a look at what was created. I'm going to use this tool called K8s, which is called a TUI, a terminal user interface for Kubernetes. And I'm going to type :pods, and this is going to show me all of the pods in the cluster. Well, first of all, I need to switch to the all namespace so I can see everything. It's kind of got Vim key bindings mixed in a little bit, so I can do /tailscale or /tailsctl, and it will pick up what I've written. So I can do a few things. I can attach into the container if I want to. I can view the logs. I can do port forwarding. I can get a shell. I just want to see the logs right now, so I'm just going to press L. It's going to show me all the logs that the operator has been creating. We can see there's a bunch of stuff happened, and now this node appears as a node on my Tailnet. So I can do Tailscale status. There's a lot in here today to do a Kubernetes video, I tell you. It's a tricky topic to cover on YouTube. There's a lot going on, but we'll get there. We'll get there. We have a working cluster now with a Tailscale operator installed. Let me show you something. I'm going to bring up a new terminal window over here, completely fresh one, and I'm going to do kubectl get nodes. Now it's going to have no idea what I'm talking about. I haven't given the shell any context about where my kubeconfig file lives. And so what I want to do is configure the API proxy so that I can now log into this cluster using my Tailscale identity. So we'll come back to this screen in a few minutes. We're going to jump back to the documentation because there is a whole section here about using the Kubernetes control plane with the Tailscale API server proxy. Now, it's a very long document here, and there's a lot of steps to follow, but I'll try and make it as quick as I can by adding just straight into my grants here. I hope you've got the idea about how to access all of this stuff in your admin console by now. Let me just add this to the bottom of this file. This is going to use I don't actually have the readers tag right here, so I'm going to have to create that tag. Readers. This will become apparent as to why we do this later on. So this is so we can map. Oh yes, I already have a grants object. So let me delete this grants object here and just simply move this configuration inside the grants stanza. And this K8s reader tag is going to map to a specific cluster role binding, I think, inside the cluster, so that we can map who's allowed to see what through the API proxy. So this is really useful if you have a Tailnet with 20, 30, 40 people at your company and you want to access, you want to give developers access to specific resources within the cluster, specific namespaces, whatever. You don't want everybody having cluster admin, of course. This is how you control that. We're going to upgrade the deployment of our Helm chart here by adding this set string API server config mode equals true. So I'm going to go back to here and then paste that in there and we should be good to go. Now with that Helm update where we've done the API server proxy config equals true, we should now be able to connect into the cluster using that random terminal window and some Tailscale magic. So this is going to fail, but we're expecting it to fail because we haven't allowed the correct permissions in our ACLs. But let's just configure our kubeconfig in here briefly. So we want to do Tailscale configure kubeconfig. We then need to supply the host name of the Tailscale operator or the API object within inside our Tailnet. Now, in this case, we haven't configured anything to do with proxy groups or any highly available stuff using Tailscale services like I mentioned earlier. That will probably come in a future video because this is probably already getting quite long enough as a video. So we'll do Tailscale configure, and what I want to do is do Tailscale status and look for the host name in our Tailnet that looks the most appropriate. In this case, it's going to be Tailscale operator. So I'm going to do kubeconfig and then put the host name of that operator into the configure command right here. This is now going to configure a kubeconfig to use the Tailscale operator as an API proxy and then use my identity within the Tailnet to present that to the cluster and say, Gandalf mode, you shall not pass or you shall pass, depending on what the rules say. So let's just do something really basic like get nodes. Okay, this is what I expected to see. This user is forbidden. A tail_and_scales@gmail is forbidden to access the API group at the cluster scope. And this is because we haven't mapped the user groups in our ACLs to the user groups and the role bindings and all that kind of stuff within inside the Kubernetes cluster. So let's do that. Now we'll come back to this window in just a second, but we need to do something to do with masters. Now, I am going to just simply add my user here of a tail and scales into this user group masters. So I'm going to copy that from here and put it into my grants right here. And rather than having group prod, I think I'm actually just going to have group admin. I think that might be the one. Yeah, group admin, that looks good to me. So let's modify this one as saying group prod. Let's change that to admin. And we should now be good to go. So let's give that another try. And voila, that's it. You never have to log into your Kubernetes cluster ever again. Now, there's a whole bunch more stuff you can do with the operator, which I won't get into today because, as I say, this video is probably getting quite long. And the focus really isn't the operator today. That will be a whole separate video. The focus today was getting you out of the ground with a Talos cluster, admittedly a single node cluster, and also showing you how you can configure the operator to operate within, a good pun, how you can configure the operator to operate within that envelope of just a single Kubernetes cluster. Now with Talos, of course, you can scale this thing up to as many nodes and as different architectures as you want. And the Tailscale operator will, of course, like any other Kubernetes service, scale with you and your needs as you grow. It's an incredibly powerful thing, and I've really only been picking this up for the last couple of weeks, like I said at the beginning of the video, since KubeCon. I've largely ignored the operator at my peril, actually, and it's I still kind of maintain that anybody that's doing Kubernetes in the home lab is mildly insane. I probably include myself in that category after the last couple of weeks of messing about. I have been putting a huge amount of time and effort into a repository called Ironic Badger, that's me, on GitHub, /K8s. So let's just take a quick look at that, because there is a whole bunch of stuff in here. There are files to automate the creation of virtual machines using Terraform and OpenTofu on top of Proxmox. There's a bunch of bare metal stuff that I've been figuring out with that little Lenovo cluster behind me there. I've done a bunch of stuff, and these are all video ideas, by the way, where we've got self-hosted Terraform state in self-hosted Garage S3 buckets on the back end because OpenTofu doesn't support anything. Terraform doesn't support anything other than Terraform Cloud and Amazon S3, and this is a rabbit hole. I warn you, and I'm sure if you're this far in the video, you probably already know how much fun Kubernetes can be, or not. It's one of those, like, it reminds me very much of Factorio. I'm sure some of you know, but I'm a Factorio like mega nerd. I've got like 1,500 hours in that game. This bit me just as hard over the last couple of weeks as any Factorio binge. But I would probably equate doing home lab Kubernetes to like learning Factorio when you've already got to Aquilo and you've got your mega spaceship, but you realize that the reason that you've run out of all of your resources in planet number 4 is because of a single iron patch 4 planets ago has run out. And that's been my experience with Kubernetes, to be honest with you. Anyway, these will all be separate videos, so please do get subscribed to the channel because there's going to be a bunch of Kubernetes content coming out over the next few months. as we dive deeper into the world of pods and Kubernetes. And we won't all be on Talos, but certainly anything that I do on premise, I can't see any reason to use anything else other than Talos Linux at this point. It's the experience of using Talos has just been joyful. And I really genuinely implore you to go and take a look at it. If you're remotely interested in Kubernetes on premise, Talos really should be at the top of your list for investigations. Let me know in the comments what else you want to see when it comes to Kubernetes content on the channel. Like I say, I'm going to focus on the main 3 pillars of the Kubernetes operator from Tailscale. So the API proxy that I showed off already, ingress to automate the generation of .tsnet certificates for all of your cluster workloads, egress, as well as multi-cluster, cross-cluster communication. Those are the main things I'm going to focus on. But if you're having any issues with any specific apps, like I was with Headlamp, for example, let me know. Come find me on the Discord at discord.gg/tailscale. You can find me in the channel in the comments. You look for Alex KTZ on Discord. You can find me over there. But that's the end of this rather long sort of introductory video to Talos Linux and the Tailscale operator. So thank you so much for watching, as always. And until next time, I've been Alex from Tailscale.